Let us do a quick recapitulation of the chapter Trigonometry. What is trigonometry? It is a branch of mathematics which deals with the relation between angles and lengths of sides of the triangle. It is the relationship between the angles and lengths of sides of the triangle. It is used to find, where is it used? For finding the heights, distances and slopes by using the properties of triangle. Before talking about the trigonometric ratios, first let us understand the three things which are used to define the trigonometric ratios, that is opposite side, adjacent side and hypotenuse. So, if we take a right angled triangle here, so this is another right angled triangle. Let us mark the vertices. This is A, B, C, and the right angle is at vertex B. Let the angle B that we are considering here be A, and in this triangle, let this triangle be P, Q and R, right. So, in this triangle, suppose our angle is at, we are considering the angle R, let this be theta. So, with respect to this theta, what is the hypotenuse, what is the opposite side and what is the adjacent side, we will see. The side opposite to the 90 degrees is called as hypotenuse. Okay, the side opposite to the 90 degrees is called as hypotenuse, and the side opposite to the angle which we are considering with respect to the angle A, that is here it is measure is given as theta. So, with respect to angle A, what is the opposite side of angle A or theta? It is BC. So, this is the opposite side. Now, the side AB is the adjacent side. You may be thinking that both AB and AC are adjacent side. So, which one to consider as adjacent and which one to consider as hypotenuse? So, first that is why we have first marked the side AC as hypotenuse, because the side opposite to AC, the side opposite to 90 degrees, that is AC is the hypotenuse, and the another adjacent side is the, we are considering it as adjacent side. And in a right angle triangle, the hypotenuse is the longest side. If you take this triangle PQR with respect to angle theta, we have to mark what is the opposite and what is the adjacent. First of all, let us see the right angle. Here the right angle is at vertex Q. So, the side opposite to right angle is our hypotenuse. And then the side opposite to this theta is our opposite side. And the leftover side is our adjacent, because this is the adjacent side of these two are the adjacent. So, if this is hypotenuse, this one is the adjacent side. So, with respect to the angle, the opposite side and the adjacent side will be different. Here, because this with respect to angle A, opposite side was BC and the adjacent side was AB, but here with respect to angle R, opposite side is PQ and adjacent side is RQ. So, you need to understand this very thoroughly. So, with respect to the angle, we have to find out, just find out the one which is opposite to that angle, that will be the opposite side. The opposite to the 90 degrees will be the hypotenuse and the another one will be the adjacent side. Now, so what are the basic trigonometric ratios you have learnt? The basic trigonometric ratios that you have learnt till now are sin theta, cos theta and tan theta. The inverses of these are, inverse of tan is cot theta, cos, inverse of cos is secant theta, and that of sin is cosecant theta. These are the short forms. We will write actual spelling of sin is SINE, this is COSINE, cosine, this is tangent TANGENT, and this is cotangent, and this is secant, and this is cosecant. Here what we need to, now look at this, the full form of cosec is cosecant. Now this order you should remember, so that when we are finding the values of these ratios, it will be easy. We will be using this sentence, that is old Harry and his old aunt. So old Harry and his old aunt, this is the sentence you should remember, so that you can easily remember the ratios. So sin theta is actually, if you take a triangle, if you take a right angled triangle like this, so suppose this is the right angled triangle A B C. So if we are finding the trigonometric ratios with respect to angle A, then let the angle be, we are considering the angle A. Now this is 90 degrees, right? So sin theta is nothing but, if this is 90 degrees, this is hypotenuse and this is opposite to this one, so this is opposite side and this one is adjacent side. So sin theta, if you want to find the value of sin theta, you will get, how would you find? O by H, that is opposite by hypotenuse, opposite by hypotenuse, because for the same angle, whatever we take the side, the ratio will be the same thing. If we increase the size also, the ratio will be the same. So cos theta is equals to adjacent by hypotenuse, and then tan theta is equals to opposite by adjacent. Now just remembering this like this is difficult, so we will be using this old Harry and his old aunt. So sin theta is nothing but, so first we are writing it in order, sin, cos, tan, then we are using this to form the acronym, that is old Harry and his old aunt. Now we know that cot is the inverse of tan, so it will be A by O, and sin is, secant is the inverse of, multiplicative inverse of cos, so it will be the reverse of this one, that is hypotenuse by adjacent, and cosecant is the multiplicative inverse of sin, that is sin is O by H, so cosecant will be H by O. Should be very thorough with these things. Now let us write it, as we have said that sin is the multiplicative inverse of cosecant, right? So sin theta can be written as 1 by cosecant theta, or this cosecant theta can be written as 1 by sin theta. Similarly, tan and cot are multiplicative inverses. So tan theta can be written as 1 by cot theta, or this cot theta can be written as 1 by tan theta, 1 upon tan theta. And one more thing, sin and cosecant are inverses of each other, tan and cot are inverses of each other. What is left out? Cos. So, cos theta is the multiplicative inverse of secant theta, or we can say that secant theta can be written as 1 by cos theta. So, these are the things you should be very thorough about. Then we have the standard angles. The standard angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. For these standard angles, we will find the values of sine, cos, tan and so on. So, for that, if we remember the sine values, we can calculate all other values. But these sine values can also be obtained. There is a trick for this. First, what we have to write? We have to write 0, 1, 2, 3, 4. Before this, I would like to say that you should be thorough about these values. You should be remembering this very well. But the thing is, you should have the knowledge of this too. So, for this, what we are doing? First, we are writing from 0 to 4. Then what we are doing? We are dividing all these numbers by 4. 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. Then we are applying the square root for each of these. So, 0 by 4 is 0. So, square root of 0 is again 0. That way you are getting sine 0 is equals to 0, and 1 by 4 under root is 1 by 2. 4 under root it will become 2. Now, 2 by 4 upon cancellation you will get 2 1s are 2, 2 2s are 4. So, 1 by root 2. This one solved you will get root 3, root 4 is 2. So, root 3 by 2, and 4 and 4 will get cancelled. So, the value remained is 1. So, square root of 1 you will get it as 1. So, what is sine 0 value? Sine 0 is 0, 30, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2 and sine 90 is 1. Now, cos values are just, if you observe, we are writing the reverse, the same values in the reverse order. So, cos 0 will be 1, cos 30 will be root 3 by 2, cos 45 will be same as sine 45, then cos 60 is 1 by 2 and cos 90 is 0. What did we do here? Just these values are placed in reverse order. Now, we know that sine theta is equals to tan theta is equals to sine theta by cos theta. So, tan theta we can find the value of tan 0 degrees by sine 0 by cos 0, that is 0 by 1 is 0, 1 by 2 by root 3 by 2, 2 and 2 will get cancelled. What will be left is 1 by root 3, then 1 by root 2 and 1 by root 2 will be cancelled, 1 will remain. Then here also root 3 by 2 upon 1 by 2, 2 and 2 will get cancelled, root 3 is left, 1 by 0 is undefined or infinity. Now, the cot values, simply we can get the cot values by placing these values in the reverse order, infinity, then here root 3, tan 45 and cot 45 both are 1, this tan 30 will be equal to cot 60 and cot 90 will be equal to tan 0. Just we have placed these values in the reverse order. Okay. Coming to the next one, that is secant. We know that secant theta is equals to 1 by cos theta. So, 1 upon 1 is 1, 1 upon root 3 by 2 is 2 by root 3. Just we are writing the reciprocal of it. Then 1 upon root 2 is root 2, 1 upon 1 by 2 is 2 and 1 upon 0 is infinity. 1 divided by 0 is infinity. Similarly, we can get cosecant value by placing the values of secant in the reverse order. First infinity, then 2, then root 2, then 2 by root 3 and 1. So, you should be very thorough with the values, with these values, so that whatever the calculations are there, you can do it simply. The next thing that we are going to learn is complementary angles. What are complementary angles? If the sum of two angles is 90 degrees, then each of the angles is called as complementary angles. A and B are, in this case, A and B are said to be, angle A and angle B are said to be, each one of them are said to be complementary angles. Now, if we, in trigonometry also we have complementary angles. So, sine 90, what the complementary angles are? Sine theta is equals to cos 90 minus theta, the first one. Okay. Similarly, cos theta is equals to sine 90 minus theta. The second one, tan 90 minus theta is equals to cot theta, and cot 90 minus theta is equals to tan theta. This is one of that. The third one is secant 90 minus theta is equals to cosec theta. Then cosec 90 minus theta is equals to sec theta. Okay. These are the things we have to memorize. Sin theta is equals to cos 90 minus theta, and the same way cos theta can be written as sin 90 minus theta. Tan 90 minus theta can be written as cot theta, whereas cot 90 minus theta can be written as tan theta. Secant 90 minus theta can be written as cosecant theta, and cosecant 90 minus theta can be written as secant theta. Then we have trigonometric identities. So, what are the trigonometric identities? Trigonometric identities we have. So, we have 3 identities, and from that we can identities. Okay. From that we can derive more, that is sine square, the first being sine square theta plus cos square theta is equals to 1, and then we have secant square theta minus tan square theta is equals to 1, and the third being cosecant square theta minus cot square theta is equals to 1. So, let us see this carefully. From this we can calculate the value of just secant theta and cosecant theta. I mean cosecant theta or theta, tan theta. Cosecant theta, just cosecant theta or cot theta. Let us see how we can do that. So, coming to this, we can transpose here, right? So, in this case we can transpose, like sine square theta is equals to 1 minus cos square theta, isn't it? So, when we are transposing this cos square theta through the RHS, it will become minus cos square theta. Now, I want the value of sine theta, just sine theta. This square when transposed, it will become root. So, 1 minus cos square theta. The second thing is, now I will be transposing cos and not sine. I mean I will be transposing sine and not cos. So, cos square theta is equals to 1 minus sine square theta. That is, if I transpose the square, cos theta is equals to square when transposed, it will become square root. So, 1 minus sine square theta. So, from this only we can find the value of just sine theta and cos theta. Similarly, if I transpose this tan square theta to the RHS, it will become, let us see, secant square theta is equals to 1 plus tan square theta. Now, if I want to find just secant theta value, the square will be transposed and it will become square root. So, square root of 1 plus tan square theta. Similarly, if I am transposing this tan, so this 1 to the LHS and tan theta to the tan square theta to the RHS. So, I will get secant square theta minus 1 is equals to this minus tan square theta will become plus tan square theta. Then tan square theta. Now, tan theta can be written as, if I transpose this square to the LHS, it will become square root of secant square theta minus 1. So, we should be able to find the values of just secant theta or tan theta from this identity as well. The third and the last one is cosecant square theta minus cot square theta is equals to 1. Let us transpose this cot square theta. So, it will become 1 plus cot square theta. Now, if we transpose this square, we will get cosecant theta is equals to under root 1 plus cot square theta. And similarly, if I transpose cot square theta in this time at this time, so I will get cosecant square theta, and 1 if I bring it to the LHS, it will become minus 1 from this one, okay, is equals to transposing cot square theta, it will become positive cot square theta. Now, if we can also transpose this 2 to the LHS, so it will become square root of cosecant square theta minus 1 is equals to cot theta. Basically, these are the things which we will be using in this, and let us also recapitulate the Pythagoras theorem that is used most of the times. And for this also, for the Pythagoras theorem also, we will be using a right angled triangle. So, what is Pythagoras theorem? What did we learn? That if this is the hypotenuse, this is the base and this is the height, then what does Pythagoras theorem state? The Pythagorean that hypotenuse square is equals to, the Pythagoras theorem states that hypotenuse square is equals to base square plus height square. In this case, what is hypotenuse? So, AC square is equals to AB square plus BC square. Okay, this is the Pythagoras theorem. So, we are well aware of all the basic things of trigonometry. Now, we can easily solve the exercise problems. Quick recapitulation of this chapter, you can go through this mind map. Also, you can take a screenshot of this one.